You see the counter going?
Yeah.
Okay. Let's rock. Okay, so we are going to wrap up chapter 13 today. I actually, as I went back to the test, we've actually covered everything that is on the test from chapter. Sorry, we've actually covered everything that is on the test that's new material. Okay, so what I'm going to do is I'm basically going to highlight chapter 13. I don't want to say review, but basically we're going to review chapter 13. I went through the test again, and I've basically broken it down into 6 days, and we're going to cover 15 questions every day. Okay, I figure in a half an hour, 45 minutes, we ought to be able to cover 15 questions, don't you think? So what I've done is I've gone through, and this is roughly, this right here though is about 25 questions, just because today is basically a 13-day still on my calendar the way I broke it down. So this is going to be only test questions that are based on chapter 13. Alrighty? And this is them. Okay? Okay, you're going to have to speak louder.
Is chapter 13 the same as the final, or one?
No, they're all together. Okay, so what you need to understand is the final consists of 80 questions. Okay? You know what? Let me write this down so everybody understands this. Okay, so it is 424. Okay, so the final is really 13 plus cumulative review is what it is. Does that make sense? Okay, so chapter 13 consists of about 25 questions. Cumulative review then is the other 55 questions. Give or take a couple. Does that make sense? But yeah, we have one test left. Okay, and that test, which is the final, if you recall, is going to be on 5/15 at 10 a.m. So you need to plan accordingly. Are we all hearing the words that come out of my mouth?
After the final, are we don't have anything left for this class and never gonna see you again?
Are you a senior?
What?
Are you a senior?
No, I'm a junior, but...
I'll see you next year.
But after the final, we're not gonna have class again?
Nope.
Okay.
Now, I do reserve the right. Now, Sierra brings up a good point. I don't know if you guys have been hearing what's going on. They are still trying to decide what we're going to do for graduation. They are still trying to decide all that stuff. So if they were to push graduation back to, say, instead of, that first Tuesday, they were to push it back to maybe that Friday, we could push this test back. But I'm going to be honest, I don't know if it would do us any good. I think, 6 days review is plenty. What do you guys think?
I think that's fine.
So I only have one student that has an opinion on that.
The U.S. History AP test is that same day, but it's not till noon. But that's just something.
Oh, I'm not sure. Who was that?
Savannah Clark.
So I'm not sure what... Oh, man. You know what? I'm going to send an email out to the school. I'll go school-wide on this because that's a great point, Savannah. And let me see what the what the schedule looks like, because typically if we were in school, we would know all these dates, you know what I mean? But no one has said anything about that, and I would rather not take something on the same day. I mean, not that it bothers me, but I would rather not have you guys take something on the same day. So let me look into that and see what I can find. Okay, Savannah?
Okay.
That sucks though, because the AP tests are through May 11th through the 15th and May 18th through the 22nd. So it's kind of like...
So no matter what, I'm going to overlap, is what you're telling me, Yuri?
Yeah.
Shoot. Alrighty. So here's my next question then, and Savannah brought it up. How many other students have a test that same day? Anybody besides Savannah in that class?
I do.
So that's 2 of you?
I'm in that class too.
So that's 3 of you? I'll still send that email out, Savannah, and we'll see if there's nothing. If there's nothing I can do to change that, we'll just have to do it the same day. Sorry, guys. I don't know what else to do. You know what I mean?
Fine.
What?
It'll be fine.
Alrighty. Okay. Alrighty. So, what we're going to do is I'm going to go down through this 3x5, and we're going to just talk about it, and then I'm going to give you some time. Is Hannah still on here? No, Hannah? Okay, what are we up to number-wise? 60? Alright, let's get going. Okay, so, you got to make sure you understand the difference between an alkane, and an alkyne. Okay? Now, one thing I did notice is that they do give you a couple of these where you've got to make sure you understand the formula for them. Now, if I have an alkane, it's CX, it's H what? Anybody know what this little formula is here? Nobody remember? Yeah, it was 2x plus 2. How about an alkene? If it's CX, it's H what? Just 2x. And how about an alkyne? If it's CX, it's H what? Anybody? I don't know if we've covered this one before. You see a pattern here. It is 8. It's 2x minus 2. That's an alkyne. Now, the only thing you need to understand is that this only works if there is just one double bond. Okay? Meaning the bare minimum to make it an alkane. Here, there's just one triple bond, which is the bare minimum to make it an alkyne. Does that make sense?
Yeah.
Okay? Now, from there, something we talked about, I believe, just the other day was the difference between a constitutional isomer versus a stereo isomer. Okay? Anybody remember what the definition of a constitutional isomer was?
Same formula, different arrangement.
Same formula, different arrangement, which means these can be vastly different compounds. Whereas in a stereoisomer, the only thing that changes is what?
It's 3D arrangement.
It's 3D arrangement. So the only difference is the 3D arrangement. And I said that really only applied to what 2 words? Yeah, this is cis or trans. So I know that this is going to be, most of the time, this is when I had an alkene, right? That's when I had an alkene, typically, is the only thing that applied to there, okay? So just make sure you understand that. Now, the largest portion of Chapter 13 is naming of compounds. Naming compounds. Now, thing you need to understand here is that you've got to be able to do this both ways, which means, what do you think? Anybody know what I mean when I say both ways there?
Take a name to the structure or a structure to the name.
Now, I think we are pretty good on structure to name. I do not think that we are very good on name to structure. Okay? So what we're going to do is we're going to do a couple of backwards ones. Okay? And I'm going to do one, and then I'm actually going to have you guys do Raisy Handy game for a couple of these. Does that work?
Yeah.
Okay, so this is what I want. So we're going to go with O-dichlorobenzene. Okay? So I want to do this. So who can tell me what they think I should do first? Draw the benzene. So what does that mean I'm going to draw? Okay, so I'm going to draw basically a hexagon, right? And how do I have to make sure I put in my double bonds? Alternates like that, and like that, it'd work, right? Now, it's dichloro, which means it's got two what? Two chlorines on it. Where are those chlorines going to be at? Which was O? Because remember, I've got O, M, and P, right? Ortho, meta, para. Ortho is what? Next to. Para was, meta was one space, para was opposite. So, does it matter where I put these chlorines, really? No, as long as they're what? Right next to each other, right? So, if I was going to do this, it would be, if I go Cl there, I've got to go Cl there or there, right? And that would be O, right? Ortho dichlorobenzene. Does that make sense? Alright, so let's do this one. So, now this is going to go lazy handy, so let's pay attention. So I'm going to start out easy. I'm going to go pentyl benzene. Okay, and let's go for 10 hands. I want you to draw pentyl benzene. And go. While you're doing that, I'm going to blow it up. I've got 1, 2,
3,
4, 5, 6, 8,
9.
You gonna get one more?
The last number, I was going to try.
We were at 9.
10.
10, alright. Okay, so Dodge, were you number 8?
Yes, I was.
Yeah, that's right, I know your voice. What'd you do first?
I drew the benzene.
Okay, so where did you put your double bonds? Here or there?
I'd say there.
There? So I went there, I went there, and I went there. Okay, then what'd you do? So how many lines you got?
1, 2, 3, 4, 5.
Like that?
Something like that.
Is he right? Could that be pentobenzene?
Yeah.
Yeah. Now my question is why is that not 1 pentobenzene?
Like having 1X. You don't do 1X.
Exactly. If there's only one branch, you don't have to number it because you know that wherever it is, that's where you would have to start counting. That makes sense? Yes or no?
Yes.
Alrighty. Here comes another one. I want you to draw 4-bromo dash 3-chloro toluene. 4-bromo dash 3-chloro toluene. So let's go for 12 hands this time. 12 hands.
One.
2,
2, 3, 4.
4,
All those all.
6.
7.
8,
9. 10.
2 more.
11. Well,
Alrighty. So who is 4?
that's me.
Alrighty. Who is that?
Pause.
Who?
Aaron Hall.
Oh, Aaron. Hey. Alright. So Aaron, what do I do first?
So you draw the toluene, so
Okay.
you got a benzene attached to a CH3.
So I got a benzene. So if I went there, there, and there. So here's my question: is where does that extra carbon need to go? Does it really matter?
No, it doesn't.
So let's say I put it right there, and let's say that's my CH3. That's what makes it my toluene, right? So what do I know about that right here? What do I know about that?
That's your number 1.
Has to be my number 1. So where does my number 2 have to be?
Across the double bond.
So I got to go 1, 2, 3, 4, 5, 6. Correct? Would that be numbered correctly?
Yeah.
Okay. So based on that, then what am I going to do?
So at your 4, you've got a Br, and at your 3, you've got a chlorine.
Just like that. Is he right?
Can I ask a question?
Yo!
So, usually you always have to go across the double bond, but on the Learn Smart, there's a few questions where it doesn't do.
Okay, so there are a couple of things that take precedence in that situation, and if you go back to, I talked about this the other day. Does anybody remember we did one of these that didn't do that? Does anybody remember what it was? I can't remember, but you're right. There is a couple of situations where, because I'm going to get a lower sum, I would not cross that double bond first. Does that make sense?
Yeah.
So when I look at that, you don't happen to have one of those, or remember what it was, do you, Tolman?
No, I don't.
Yeah, but I do remember looking at that and thinking to myself, okay, that is, I don't want to say an exception, but that does just apply one rule over the other. So you're right. If I can go across the double bond first, that's what I want to do. But there is a situation where if I'm going to get a lower sum going the other way, the sum is going to take precedence over crossing the double bond first.
Okay.
Does that make sense?
Yeah.
Okay, I will, but when we go to review, I will actually go back to the test and see if there are any of those exceptions, and we'll look at that. Right off the top of my head, I am not. Let me see if I can find one really quick. I wasn't prepared to answer that question, but let me see if I can see one really quick. Well, yeah, there is not there is not one question in the homework that has that on it. So do me a favor. Do you remember which Learn Smart it was on?
No.
No? Alrighty. Well, then let's do it this way. Those of you that haven't done all the okay, I'm going to assume, well, I know there is. There's a lot of you that haven't done them all. If you run into one of them, take a picture of it so I can use that as an example, because there is not one in the text that has that on it. And if I pull it out of my head, I think I'll screw it up. Do you know what I mean?
Yeah.
So let's just do that. Okay. Alrighty. Let's do we think we got this, or should we do one more?
Never hurts to do one more.
Never hurts to do one more? Alrighty, so let's look at this. So let's go with 4-chloral -1,2 diethyl benzene. Let's go to 15 on this one. So I need you to count to 15. Draw on that. 4-chloral -1,2 diethyl benzene.
One.
2.
3.
3.
4.
We have 3 threes, guys.
I did notice that.
I'll go 5, but I wasn't one of the 3s.
6.
7. 8.
7.
The last boy, you're 9. Last.
Is that where we're on?
I think you're 10.
10?
Is that Yuri?
Yeah.
Hey, can I make one suggestion?
Yeah.
I think you need a haircut, man.
When did you see me?
I've been telling him that for like months.
No, I thought, weren't you in that video?
Oh, yeah.
Right? I'm like, man, first thing is I'm watching that video, I'm like, man, Gage needs a haircut.
No,
You're growing it out?
yeah.
Really? Well, we have Mason's senior picture scheduled for tomorrow, and we had to cancel him because nobody will cut his hair. You know, Hudman, you there? Okay, let me show you something. You don't get the joke?
No.
Okay, one day you said that I made your day by having a red drink in my red cup.
I don't remember that I said that.
You did once. I was just trying to make your day again, but obviously it didn't work. Alrighty, so who's number 5?
That would be me.
Okay, Sierra, what do I got?
So we started off with the benzene.
Okay?
And then we put a ethyl group on one of them.
So if I went like that,
Yeah.
Okay.
And then the pure ethyl is going to be to the right of that.
be right here,
I meant left.
left, like that.
Yep, and then the chloral group's going to be to the left 2 bonds.
Like that.
Yeah.
Would that work?
Yeah.
Yeah, that'll work. Alright, that's that. Okay, oh, by the way, there is an Easter egg on my 3x5 right here, just so you know. Okay? Just pay attention to that. Now, one thing they did talk about is melting point. Okay? So if I have a high melting point, okay, the higher the melting point, so what it does is it says which of the following would have the highest melting point. Okay? And what you're going to look for is, you're going to look for a few different things. First thing you would look for is an ability to do what? Anybody remember? What gave things high melting points? Something water does. It's an ability to what?
Dissociate?
Nope.
Dissolvable in water?
Nope.
Solubility?
Nope. All correct answers, but not what we're looking for here. Water does something that makes it special. E.T.? Think E.T.?
Hydrogen
Be a
bond?
halogen. Has to be a halogen.
Nope. It's an ability to hydrogen bond. An ability to hydrogen bond. Okay? So, what I'm going to look for is, if it gives me a list of chemicals, I'm going to look and say, is there one of those that will hydrogen bond that the others don't? Okay? Second thing I want to look for is the number of carbons. Okay? Because if you recall, the more carbons I have, the higher the melting point. Okay? And then the third thing was the fewest number of double or triple bonds. Okay? And what you got to do is you just got to look at this and say, okay, if I were to look at, let's just compare two chemicals. Let's say I did this. Let's say I did that. I did this, and I did that. Okay? And I said, which one of these is going to have the highest melting point? Okay? I would say, okay, a high melting point is an ability to hydrogen bond. Do any of them hydrogen bond? No, because none of them have an H bonded to an F and O and an N, right? Okay, so that doesn't work. And I say, okay, the one with the higher melting point is I probably should have put the higher number of carbons, right? Okay, well, they all have 3 carbons, so does that one apply to my answer? No, so I say, okay, the one with the fewest number of double or triple bonds. Okay, well, this one has 2 triple bonds, right? This one, or 2 double bonds. This one has 1 double bond. This one has no double bond. So that would be the one with the what? That would be the fewest number of double or triple bonds. So this one would have the highest melting point. Does that make sense? Or no?
Yes.
Okay. And there's I want to say 2 questions along those veins. They just go through different ones of these. Does that make, you see what I'm saying? Like one of them, they go over one of them, and then another question, they do it using a different way to look at it. Okay? Something we went over last time that there are several questions on, and they are the 4 types of reactions. Anybody remember what they were? I gave you 4 types of reactions yesterday. Or not yesterday, on Wednesdays. Anybody remember what they were?
Hydration.
Okay, so I got hydration. I got what?
Halogenation.
Halogenation. What else? Hydrohalogenation. And hydrogenation, right? Okay, what do I need to remember here for any of those? Do you remember? There's a couple of unique things I've got to remember here. Nobody remembers anything about hydration?
That one breaks the double bond.
All of these are going to do that. All of these will break that double bond. But hydration,
H2O.
yeah, well I am, but there's something else that has to happen there. Anybody remember?
The H goes to the part that has the most amount of H's.
Okay, so that was, do you remember what that was? What that was called? Markovnikov's rule. Okay, you're right, that's there, but that's not what I'm after here. Hydration required something special.
Oh, the region,
A catalyst, thank you. What was it, do you remember?
Hydrochloric acid.
Nope.
PD?
Nope. H2SO4. Water required H2SO4. So that was H2O plus H2SO4. Halogenation, well, what were my main options here? I gave you the 2 common ones. Cl2 and Br2. You're right. What about hydrohalogenation? Was there anything there?
Like hydrogen attached to a halogen.
Yep, so like, yeah, so it's like HCl or HBr, one of those 2, right? Okay, did either of these 2 require a catalyst?
No.
No. What about hydrogenation? What was added there?
H2 and then PD.
Yeah, H2 and palladium as a catalyst, right? So remember, catalyst and catalyst. I also have to remember Markovnikov's, right? Where the rich get richer, as Sierra pointed out earlier. Okay, wait a minute, there was one. Halogenation, okay, and these are the 2 they used, but when they did this in the book, they only, like when they showed an example, they only showed this one. And I want to say they asked a homework question about this, but with CO2, it required FeCl3 as well. Anybody remember me talking about that? Anybody have that written down? I'm trying to remember. I thought I mentioned that. No?
Nope.
I did not write that down. Nope, you're right. Well, I am now. Okay? So, just a minute. Because it wasn't last time, it must have been the time before.
This was the first time that you've actually not had something written down that you were like, go look back at it, you'll see.
No, you're right. FeCl3, though, is right there. And I know that's in the book, but you're right, I don't have that. I'm looking right at my notes. And that's when I taught it with Markovnikov's rule. And I forgot to put that catalyst on there. So yeah, FeCl3. I'll show you. Give me a second. Because when I went back today, I was looking at that and I thought, man, I better address that. So where was that at? Let me find it. Give me 1 second, I'll find that. Huh. It's not there. Where did I... Oh, I think I just gave something away. Huh. I'm going to have to look at that because they don't do this in the book, but I think I just gave something away right there. They must do that on the test. Remind me to look at that right there. Okay? What? Yeah, that was not the Easter egg. No, sorry. But I will need to go back and look at that. I just don't have the test in front of me right now. Okay? Alrighty, from there, you need to know what it means to be an aromatic. Anybody remember what it meant to be an aromatic? Has to do something. Nobody remembers what it meant to be an aromatic?
On the benzene ring?
Yeah, it must contain a benzene ring. And they are clever. They are clever. Let's say I did this. Is that an aromatic compound?
No.
Not an aromatic. Why?
It needs 3 double bonds.
Yeah, it's got to have 3 double bonds in it. So make sure I pay attention to that. Okay? I've got a cyclical structure there, but it is not a benzene ring because it doesn't have that 3rd double bond. So that would not be considered an aromatic. Okay?
What if it has 3 double bonds? So like there's an extra one between 2 of them.
So it would have 4 double bonds?
Yeah.
Then still, does that make it a benzene ring?
I'm guessing no.
No, it's got to have 3 alternating double bonds to be a benzene ring. Very specific to be an aromatic. Okay? That makes sense?
Yeah.
Alrighty, and then the last thing I wanted to talk about was monomers and polymers. Okay? Now, they do this both ways. Okay? In one question, they give you a polymer and say which monomer created this polymer, right? So you just got to go and kind of break that down and see which, the repeating pattern. Does that make sense?
Mm-hmm.
So if I did, let's see, let's say I did this. Let's say I gave you this, okay? If I did that, would you be able to tell me what the monomer is that created that polymer? Yeah, all you gotta do is find the repeating pattern, right? Well, if I look at that, clearly, if I go there and I go there, those 3 are all identical compounds, right? Aren't they?
Yeah.
So then the monomer would be basically, if I looked at that, remember, if it wanted me to draw that, what would the molecule I draw have to have in it? What happened when I created a polymer? What always broke? The double bond, right? So where would my double bond have to be in this molecule?
In between the 2 C's.
Yeah, so I would go like this. I would go C, H2, double bond C, H, Cl like that, right? So then that double bond breaks. Half of it goes out there and creates that bond. the other half goes out there and creates that bond, and that's where I get that situation. Does that make sense? Or no? Does? Do you want to do it this way or the other way?
The other way.
So go from a monomer to a polymer. So I would do something like this. Let's say I had this. Let's say I did that, right? Okay, well, what do I know is going to happen to that double bond? The double bond is going to break. Half of that bond is going to swing out there. The other half is going to swing out there, right? So I look at that, I would get line to my C. That's that C, right? And I would have F. I would have BR. Then I've got that C with that F and that CL, right? And then next to it, I would just take this and do what to it? Nobody?
Copy and paste it over.
Basically, exactly. Right? And then I would just do it again. And it would look something like that. You can see that repeating pattern of monomer, polymer. Questions?
Yeah.
Does that make sense?
So, I have a question.
Yeah.
So if they were asking for the monomer, would that be the double bond, or would it just be like the C, that could just be like without the double bond?
No, you would go back. So that's a great question. So if they want the polymer, no double bonds will be there. But if they want the monomer, it's got to have that double bond in it.
Okay.
Do you see the difference there? This must have double bond. This will not have double bond. That makes sense?
Yeah.
Okay. Anybody else? Okay, that's everything I've got. One last look at my 3x5. I will have this video up. What number are we at? We still at 60?
Yeah.
Yeah.
Okay. So, any questions out there?
Yeah.
Go for it.
Will you do one based on the Markov rule?
Yes. Yeah. So let's do. Let me find a good one here. All right, so let's do this. So let's say I've got pretty sure how that looks like. So let's say that's what I do. Let's say this is what I've got. Okay? So, I know that my HCl bond's going to break, right? It's going to split, and this H is going to go somewhere, and that Cl is going to go somewhere else, right? Now, in this one, same thing. That double bond's going to break, right? Half of it's going to go here, half of it's going to go there. Where does the H go? Where does the Cl go? Anybody want to take a stab at that?
Does the H go with H and the Cl go with C?
Why?
Because the H has
Exactly. This has one H, this has no H's, right? The rich get richer, so the one that has an H gets the H, the one that didn't have the H gets the CO. Rich get richer. Does that make sense?
I'm confused.
Okay?
What about the CH3?
It doesn't matter, because remember, when I'm doing this, I'm breaking the double bond, and it's got to go where that double bond is at. Let me draw just a regular structure. Let's say I did this. Okay? Let's say I gave you this, and right here I had a CH2, CH3. Let's say I gave you this, right? Okay? And I'm going to add to this, let's say I'm going to add to here, let's say I add H2O, and I also have H2SO4 here, okay? Now, I know my H2O is really going to give me H and an OH, right? Like that, correct? Right, this is hydration. Now, I know this double bond is going to break, right? Okay? Half of it's going to go here, half of it's going to go there, right? Right now, this is a tertiary carbon, because it's got 1, 2, 3 bonds, the other one was an H, right? So I know this one already had one H, right? Okay? Whereas down here, how many H's did this carbon have? Let's just do this. Well, look at it. It's bonded to 1, 2, 3, 4 carbons, right? So it was quaternary, so it didn't have any H's, did it? There were no H's around it. So if this one doesn't have any H's, that's got to be where the OH goes. This one had one H, that's got to be where that H goes. That make more sense? Then it would have had H and H, and then that would have had that on it. Sometimes it helps to just draw it out and put all the H's in, and then that way you know where that H has to go. You see what I'm saying?
Yeah.
Okay? Anybody have anything? I know Tolman asked me a question. Does anybody have any questions? I would like to congratulate Hannah Staley. She's done everything. She's done. All done with her homework. That's got to feel good for her. Anybody got any questions? Or I have 18 that haven't done anything, and they're all going to get phone calls from the great one today. So, anybody else got anything they want to look at? Okay, well, I'm going to leave this. Go ahead.
I have a question about note cards for the test.
Both double-sided. You get double-sided.
Okay.
Double-sided 3x5. Anybody else? Okay, well, I'm gonna leave my this meet open for a little while. If you have anything, you can just jump back on and shoot me a question, okay? Okay, I'll talk to you guys later.
Yeah, thank you.
Yep.
Thank you. Thank you.
You know you guys miss me.